Hello, this is topic 7 of Unit 5 for Calc AB, and your notes start on about page 23. And we're just taking a little bit of a pause here and looking at just kind of reviewing the 3 big theorems, IVT, MVT, and EVT. So how can you navigate those theorems is the essential question. So here's one example of how they would ask this on a multiple choice question. It says, let f be a function with selected values given in the table above. Which of the following statements must be true? So that's a high bar. That whole idea of must be true. So we know that each of these 3 theorems has a continuity and or a differentiability criterion. You need to know which ones have a which. So quick review here. The intermediate value theorem, that's the first one we learned, f is continuous on a closed interval of a to b. The mean value theorem, f must be continuous on the closed interval and differentiable on the open interval. And for the extreme value theorem, f just needs to be continuous on the closed interval. So looking at this big picture here, the only one that needs to be differentiable is the mean value theorem. That's the one where we have to calculate the algebra slope. And that's why it needs to be differentiable, is because we're finding locations where the derivative matches that value. So the other 2 don't need to be differentiable, but all 3 of them need to be continuous. So the first thing we look at when we're given a question here, and we're being asked about these 3 big value theorems, is, does it tell us that the function is continuous? And the answer is that it doesn't tell us that this function f is continuous. And so we can't make a determination about any of these statements. So the answer is A. If f were continuous on the closed interval, then we could follow through with its intermediate value statement 3. Would follow from the extreme value theorem, and statement 2 would follow from the mean value theorem. So all of the statements could be correct, but they don't have to be correct because we don't know if we have a continuous function. So the correct answer here then is A, because none of them has to be true. Must be true, like I said, that's a high bar. Let's take a look at dispelling the remaining ones. So statement 1, by the intermediate value theorem, there is a value c in the open interval from 0 to 3 such that f of c equals 2. So looking at the table from 0 to 3, our function value goes from 0 to 6. 2 is within that range. So we must be able to attain a value of 2. It's incorrect because we don't know if f is continuous, but that itself would be a correct statement if f were continuous. Let's take a look at 2. By the mean value theorem, there's a value c in the open interval from 0 to 3, such that the derivative is equal to 2. So if we calculated the algebra slope here, 6 minus 0 over 3 minus 0, that's 2. And so that would hold true because the average rate of change is 2. And so the value, there must be something on the interior where the derivative is 2 if it's a continuous and a differentiable function. But we don't know if it's continuous or differentiable, so we can't draw the conclusion. Answer D is just all of them. So which one didn't we do? 3, the extreme value theorem. So same thing, is that from 0 to 3, we don't know if we have continuity. There must be some function value that is less than all other function values for an extreme minimum, or must be bigger for an extreme maximum. But again, we have no confirmation about the continuity, so we can't say that any of those statements must be true. So the answer again is A. So, once we violate the hypothesis, we can't draw a conclusion. So we have to know it's continuous, and for the mean value theorem, we also have to know it's differentiable. Those are the hypotheses for each theorem. All right, let's take a look at this one. So it says, let G be the function given by G of x equals the square root of 1 minus sine squared x. Which of the following statements could be false on the interval from 0 to pi? So it could be false. So we just need to find one instance of a false statement. And if we look at this, we have a couple of extreme value theorem options and intermediate and the mean. So we're hitting the big three again. So the first thing is they don't mention anything about continuity or differentiability, but we have a function. And so we should be able to know if this is continuous over the closed interval, and we should be able to know if it's differentiable over the open interval. So just looking at it, we know that we could differentiate that. So we know that it's differentiable. The other thing, so this goes back to that, and it's up on the wall in the classroom, but that page on the second page of your note packet, it's on the back side of the schedule, I believe, where we have all of those functions. And we just kind of know what some very foundational functions look like. And that really helps. So if we look at this and we know our trig identities, 1 minus sine squared x is cosine squared x, and the square root of cosine squared x means square root cosine squared, and then take the positive answer. So it means the same thing as the absolute value of the cosine of x. So if you think about from 0 to pi, the cosine of x starts up at 1, swoops down to -1 at pi. That swooping from pi over 2 to pi is going to flip up above the axis, and it's going to look like this, and then like this, like kind of like a seagull or a bird flying. And so just to have that basic trig identity and that basic knowledge of what it looks like, then you can get an idea. Well, it's not differentiable because it's going to come down to pi over 2 and it's going to have a sharp cusp. So it's definitely not differentiable at pi over 2. But it is continuous. So it looks kind of like this. Here's in green, this is cosine, but this is negative, and we want the positive value of the square root of cosine squared, and that's the same as the absolute value. So it's going to come down to pi over 2 and then go back up to over to pi, go back up to 1. And so now that we have now that we've taken a second to kind of get a physical picture of the idea, we can start looking at these statements. So statement A is, by the extreme value theorem, there is a value C such that G of C is less than or equal to G of X for every function value in the domain. So this would be an absolute minimum. Okay, so that statement is incorrect because it says since G is continuous in the closed interval, it's guaranteed to have an absolute minimum at some value C, and the absolute minimum is at 0. So, which is what we just got done saying, the absolute minimum is 0 at pi over 2. So this is a true statement, which means it's not false, right? Because we're looking for false statements. So that would be an incorrect response. Let's look at response B. Response B says the extreme value theorem says there's a value C such that G of C is greater than or equal to all function values in the closed interval. So that means we would have an absolute maximum. And so, again, that's a true statement. G is continuous. We know that because we know something about this function. And the closed interval, and it has an absolute maximum. It actually it occurs in 2 locations, but the absolute maximum is 1. And it just occurs at each endpoint. And so this is not an incorrect. This is an incorrect response because it's a true statement, and we're looking for the false statement. So let's look at the intermediate value theorem statement. It says by the intermediate value theorem, there's a value C such that G of C equals G of 0 plus G of pi over 2. So when we take a look at this, the statement is true by the intermediate value theorem. So in other words, G is continuous, we know that. And what they're proclaiming here is there's a function value that is the average of the endpoint values. So it is, if we look at that, it's if we take the endpoint values, which is 1 plus 1 over 2, that equals 1, is the average value of G of 0 and G of pi. A value of C is guaranteed in the interval where that is the case. And so where we're guaranteed that value of 1. And so this is a true statement. It's also an incorrect response. So that leaves statement D, the mean value theorem. And you might have guessed by the graph, right, that that function, the absolute value of cosine of x, has a cusp at pi over 2. And so by the mean value theorem, there's a value C such that the derivative equals the average rate of change. And so the average rate of change here, G of pi minus G of 0 over pi minus 0 it's 1 over pi. And the attempt to use the mean value theorem to conclude that there's a value of C is kind of a lost attempt because the theorem requires G to be differentiable and G has a cusp at pi over 2. And we can see that by actually differentiating it, and we get this rational statement because of the radical, right? That power of a half and differentiating that. So because it's not differentiable, we can't make a conclusion about any mean value theorem statement, which means this is the option that could be false. So the correct answer here is D. Okay, so when we get into the classroom, we're really going to focus on corrections and any last questions you might have about the big three theorems. And so I can address those questions when we get to class.